Hi folks, this is homework 11 and you were asked to create the parameterized model of this assembly. The parameters that you see here are h, the thickness of the container and the cap, r, the radius of the cap and outer radius of the container, l, the height, and finally alpha, the angle that is formed here. Okay. Now you can make the parameters before actually making the model or after. I prefer to do that after the model because I can use the nominal values that I create that I have while creating the model later on for the values of the parameters. That's what I'm going to do. So let's go ahead to the CATIA interface and immediately save this product, file, save management, save as. I have a folder here, homework 11. That's good. So it's going to go there. All right. And then insert the new part in there. And I'll call this thing the container. Properties container. Container. Let me copy and paste this. And then say OK. Obviously, there are many ways of doing this thing. The way I'm going to do that is to draw the cross section and then shaft it. Okay, so on that vertical plane, I will sketch something that looks like the cross section of that container. So maybe something like this. Okay. And dimension the things that I need later on for parameterization purposes. So I want this angle, that with the thickness, that's going to be eventually h, and this one also going to be h, and the outside radius is going to be later r. Exit. Now, if I draw an axis here, once I exit this and shaft it, immediately it's going to create the model without actually having to select axis of rotation. Now, that's what I'm going to do. Okay. So here is an axis, exit. As soon as I shaft it, it's shafted against about that particular axis. Good. That's good. All the way to the top, insert. So let me do that on the top. Insert, new part. Say no, and I'm going to call this thing the lid. Right click properties, lid, and lid. Okay, we're going to make it. Double click on the lid on a convenient plane. For example, on that same vertical plane, I will sketch. Same routine. So, like so. All right, and then dimension stuff. So this is going to be H later on. That is going to be later on R. And the angle between this and this, that angle is not going to be, this angle is not going to be alpha. Let me see, what did I call this thing? Let me just see for a second. That angle is not going to be alpha, but it's going to be 90 degrees minus alpha. So that being the case, let me do it a different way. I'm going to select this and that. Uh, well, even then, it's not going to be alpha. So let me actually just do it the way it is. So that guy and this guy, this is not alpha. Just keep that in mind. It's going to be 90 minus alpha. Good. And draw an axis here so that I don't have to worry about selecting the axis of rotation on a shaft. And there we are. Okay. All right. All the way to the top. You save. Yeah, let me move this thing a little bit up so that I can see things better. Good. Now we're going to create our parameter. Okay. So we go to f of x. Here is where you create the parameters. Let's do the alpha angle first. Angle, new parameter. I'll call this thing alpha. And the current value, what I'm going to do is I'm going to click on the part and it gives you the nominal value. So it looks like right now this angle seems to be around 40, I don't know, 43. So I make this thing 45 for now. Doesn't matter, 43, 45. Apply, and then three length parameters. So change this thing to length, a new parameter. I'll call it R. The value of R, based on what I have here, is, let me see now, this is roughly 4.1, so I'll make it 4. Another one, H, which, based on what I have here, is around zero 0.3, so I'll make this thing 0.3. And finally, L, the height. Height, L. Now, unfortunately, when I did this thing, I didn't dimension that last piece, so I have to go back and dimension it. So I say, okay, I'll put down for now maybe 6. But one thing I forgot to do when I created the container was to actually dimension that. So I go back here, and what I mean is this height, okay? This is going to be later on my L, which I forgot to dimension, and I'm doing it now. Right now, it's about 3. That's fine. So exit all the way to the top, and f of x, show me according to the filtered by rename parameters right there. The only thing is that this thing right now is about 4, but I put down 6. It really doesn't matter. Okay, good. So now that we have our parameters listed here, we have to go make an equation, our equation. So click on f of x one more time. Okay, click on the product. Or if you want to do the container first, click on the container so that you don't see the dimensions for the lid. All right, let's go ahead. This guy, add a formula, is going to be L, and we can select it from the tree. Okay, that fellow is going to be R. Add a formula equal to R. This height, this is the thickness. Add a formula equal to H, and so is that one. That one also add a formula equal to H. And that angle that I created up there, add a formula equal to alpha. And if I'm not mistaken, I've done all of this. We can always check this, for example. I say, okay, if you update, that will resize according to the dimensions that I have here. Okay. Now, let me actually do the following. Let me change the R to, uh, let me change the alpha equal to 30 degrees and update. The reason I did that, I want to show you that these are not the same angle. You can see that perhaps. Or even if you go to the wireframe and look at the view from the front, for example, it's easier to see that they are not the same angle. So this angle and that angle are not the same. Or let me put this thing back to where it was. And now we're going to do the parameters for the equation. These are the relations that we created. And now we're going to do the relations for that cap. So, or let f of x, click on the LED. So this is going to be add a formula equal to R. Okay. And this is the height. This height, you see that? This should be equal to H, add the formula equal to H. The only thing is that this angle is not the same as alpha. It's 90 minus alpha. This, add the formula, equal to 90 degrees. Don't forget the DEG, 90 DEG minus alpha. Alpha, you can either select it from the tree or type it in, whatever you want. Alpha, I'll type it in, alpha. And then we say, okay. Hopefully we didn't forget anything. Let's go here. And first of all, update everything. And now they should match, unless I made a mistake. And it sure doesn't look like, as far as R goes, they match, but something is wrong as far as uh, this height. This should have been H. Did I do that? We have to go find out because I'm not sure if that is correct. Why don't we actually, before we do that, let's change the value of H, see what happens. For example, if I make H equal to 1, let's see what happens. Maybe easier to see what's happening here. Okay, and now let's check the angle. Definitely these angles don't match. So, this does not seem to, there's a problem with the alpha. So let's go, I think there's a problem with alpha. So let's go ahead and see exactly how we mention this thing. For sketch one, for this, for the container, if you go to that sketch, angle alpha is between this and that, which is fine. That's good. Yep, it's right there. Okay. Vertical and slanted. And now we're going to go exit that. We go to the lid. Where's the lid? Oh, I have to go back to the lid. Go back to the sketch for the lid. Oh, that's, oh, okay. Yeah, that's right. This is correct. Yeah, actually, they may be okay. Let's see. Maybe it's, oh, the H. Oh, let me also check the H. So go back to lid. H is this, and the value of it is 1. That's good. All right. Exit. Maybe they do match. It's kind of hard to see, but let's do the following. What I'm going to do is look at the wireframe, go all the way to the top. Let's look at the wireframe rendering and check it closely. Oh yeah, is this line, oh, this line parallel to that line? I think it is. Actually, we're not done yet. Let's go. I'm pretty sure everything is okay. I second guessed myself, but everything is okay. So let's go ahead and apply the constraints. Okay. So here's what I'm going to do. I'm going to say that this axis, the axis of this and the axis of that are coincident. And let me anchor the container. And I want to bring this thing down, put it on that. And one way to do that, there are many ways of doing it. One is to select this surface and that surface, and say they're in contact. If you update everything, they go back. Now, the only way to figure out whether everything is okay or not is just do a crazy bunch of crazy rotations, translation, whatever you want. And when you update, they should go back to where it is. And they do. Okay. Uh, I will make one more dramatic rotation. And the way I'm going to do that, I will rotate it like this. And I want to see if that works too. Update. Yeah, I'm pretty sure that's okay. Now to check that these actually are mating, one way is to change the opacity here. So for example, if you go to that part, right click properties, let's see if we can change the opacity. Yeah, that's good. And do the same thing for the other fellow. That is the lid. Right click properties on the graphics tab. Transparency, not opacity. And you can see that they are actually matching. Otherwise, they would have been lines that are not quite what they're supposed to be. Okay. So that's good. In fact, another way to confirm that they're matching is look at this view. And if you want, you can move these apart in the Z direction. And I'm pretty sure that you can see that this line and that line are parallel to each other. Good luck.